Hi everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back to the subject CHM421, which is analytical chemistry. This video we continue with our lecture on topic 1, units for quantities and concentration. But this time we will focus on the stoichiometry. The previous video is talking about the molarity, normality, molality, and also fraction. So in this video, we will discuss about the stoichiometries. So when we're talking about the stoichiometries, is quite related to the chemical equation. What is chemical equation? Chemical equation is describe the chemical reaction that gives the chemical formulas of the reactant and also the chemical formula of the products. It's shown on this slide. This is the example of chemical reaction. When we have sodium solid react with chlorine gas, it can be produced sodium chloride. So uh, you can see the chemicals on the left hand side. We call it reactants, and the chemicals on the right hand side is the product. Remember, for any chemical equation, you have to make it balanced. Two sodium, two sodium, say 2Cl2, and also 2Cl. So another things that you have to be pay attention is subscripts, not subscribe. Subscript is talking about the number of atoms, coefficient, the number in front of the chemical formula. Okay, you can recall back the balancing for the chemical equation by counting the atoms, or for the redox equation for the acidic and also the basic medium. Okay, stoichiometry. Stoichiometry is the quantitative relationship among the elements and compounds as they undergo chemical changes. Uh, Stoichiometric relationship can be by mole ratio or can be by mass ratio. So in calculation involving the chemical reaction, the important things that you should understand is the concept of limiting reagent or limiting reactant. So normally we want to calculate the yield of the product. Yield normally is the amount of product. Theoretical yield is the amount of product we expected based on the stoichiometry calculation. This one is theoretical value. Actual yield is the amount of product that obtained from the experiment. If you want to calculate the percentage, the percent yield, so the actual yield should be divided by theoretical yield and times by 100. So this is one example related to the chemical uh, equation or chemical reaction. Uh, Refer to the above equation, you have to calculate. They have several questions. They have 3 questions here. So we do it together. In this exercise, 2 moles of N2H4 react with 1 mole of N2O4 produce 3 mole of nitrogen and also 4 moles of water. So the question is, what is the number of moles, N2O4 required to react with 2.72 moles of N2H4. So it's asking you what is the mole of this one in order to react with 2.72 moles of N2H4. So we try to answer it together. The number of moles N2O4 required to react with 2.72 moles of N2H4, this one, uh, from the valence equations given in the question is like this. So meaning that you can do the stoichiometric relationship. 2 moles of N2H4 react with 1 mole of N2O4. But in the question, it's asking you about 2.72 moles of N2H4, meaning that uh, 2 moles of 2 moles of N2H4 react with 1 mole of N2O4. Therefore, for the 2.72 moles N2H4, it can react with how many moles? So X should be 2.72 times 1 divided by 2. So 2.72 times 1 divided by 2 are 1.36 mole. Okay, so this is similar with the answer given. All right, so the next question is asking you what is the number of gram of N2 produced when 2.72 moles of N2H4 consumed. So from the chemical equation, the stoichiometric relationship between the ammonia and into H4, ammonia and into H4. Uh, we know we know need to calculate here. We know two ammo into H4 will produce 3 nitrogen. So the question is asking you what is the mass of N2 if 2.72 moles of N2 consumed. So mole. So you have to calculate what is the mole of nitrogen when 2.72 moles of N2H4 consumed. Therefore, X is 2.72 times 2 divided by 2. 2.72 times 2 divided by 2 is a 2 point, sorry, it's wrong. 2.72 times 3 is not 2. times 3. Okay, times 3. So 2.72 times 3 divided by 2. Answer is 4, 4.08 mole. Before mass is asking about mass, gram. Mass N2 is 4.08 times molar mass, because mole is mass over mass, so mass is mole times molar mass. Nitrogen is 14 times 2. So 14 times 2 times 4.08, you obtain at 114, 114.24 gram. Okay, so this is similar with this one. Okay, another question is, what is the mass in gram of H2O formed when 1 gram of N2O4 react? So 1 gram of N2O4 react. So we have to calculate the mole of, we have to calculate this number of mole, the mole of, the mole of, it's not enough space, so I write it here. So mole of N2O4. Mole is a mass, so mass is 1 gram over molar mass of N2O4. N2O4 molar mass is, what is the molar mass of N2O4? 14 times 2 plus 16 times 4. So you can use your calculator. 14 times 2 plus 16 times 4, 1 over answers. So you can get 0.0149 mole. Okay, so now we check what is the relationship between N2O4 and also H2O. So we know 1 N mole N2O4 relate to 4 mole H2O. Therefore, in 1 gram of water produced, no, in 1 gram of N2O4 react, the mole number is 0.0109 mole. This will calculate here. So, what is the mole of water produced? Therefore, X is 0.0109 times 4 divided 1. So 0.0109 times 4 divided by 1. 0.0449 36 mole. So it's asking you what is the mass. The four mass H2O produced is a mole times molar mass of water is 18 gram per mole. So I hold on 0.0109 0.0109 times 4 divided by 1 0.436. So 4 0.436 0.04. Ah, yeah. 0.0436 mole. Okay, so this one it should be 0.0436 times 18. So answers 0.0436 times 18. So 0.7848. 0.7848 grams. Okay, so uh, it's almost similar. Okay, it's almost similar. All right. Okay, so this exercise, this is another exercise that you should try, even though the answer is already given. Aspirin is made by adding acetic anhydride to a water solution of salicylic acid. The equation of the reaction is follows: salicylic acid and acetic anhydride. If 1 kilogram of salicylic acid is used with 2 kilograms of acetic acid, anhydride, determine the limiting reagent. Limiting reagent meaning that is the small is the smallest mole. Okay, so we have to calculate the mole of salicylic acid and also the mole of acetic acid. From equation, we know 2 mole of C7H6O3 will react with 1 mole of C4H6O3. So from the periodic table, we can calculate the molar mass of this C7H6O3 is equivalent to 183. The molar mass of C4H6O3 equivalent to 102 gram per mole. So now, as I mentioned just now, you have to calculate the mole number of this one, the mole number of this one based on the given mass for the respective chemical. Okay, the mole number of C7H6O3 is a mass. You still remember mole? It should be mass over molar, molar mass. So the mass should be in gram and molar mass should be gram per mole minus 1. So C7 is O3 salicylic acid. The mass used 1 kilogram. So 1 kilogram is equivalent to 1,000 gram. So this one is 1,000. Sorry, this one it should be 1,000 gram, and that one should be 2,000 gram. So 1,000 gram divided with 138 gram per mole, and then you can obtain the mole number of cyclic acid. Same goes to the acetic anhydride, 2,000 gram divided with 102 gram per mole, molar mass of C4H6O3, and then you can obtain 19.6 mole of acetic acid. Okay, so uh, for example, we take the mole of salicylic acid. From the equation, we know 2 moles of this one, salicylic, will be reacted with 1 mole of acetic anhydride. So we know this one, 2 moles reacted with 1 mole. So uh, from the calculation that we did just now, the mole number of C7H6O3 is 7.25 moles. So 7.25 moles. Uh, okay. You have to do like this. This one 7.25 moles, and then how many moles? Before x 7.25 times 1 over 2. Okay, so 7.25 times 1 over 2 is 3.625 mole. Okay, it's a mole. So seems similar to the given answer. This is a mole of C4H6O3. However, from our calculation, uh, it has 19.6 mole of acetic acid. From the calculation we did just now, we have 19.6 mole of C4H6O3. Before salicylic acid, C7H6O3 is limiting reactant. Why? Because it's the smallest mole. It's the smallest mole. And acetic acid anhydride appeared in extra amount, in excess amount. Okay. Uh, all right. We done with the stoichiometry. Focus on the limiting reactant. Now we're moving forward to the atomic weight. Atomic weight is the average weight of the masses of the natural isotopes of the element. Normally, atomic weight you can obtain from the uh, periodic table. Okay, gram of atomic weight, the mass in gram of any element which is numerically equal to its atomic weight. Based on, for example, the atomic weight of carbon from the periodic table is 12.0.011 gram. What is molecular weight? Molecular weight or formula weight same similar is molar mass. normally in a unit of gram, mole, minus 1. Okay. Okay. This table is show the SI unit for several physical quantity. Is we covered previously in our earlier video. I think no need to memorize this one. It's just give you some idea of the SI unit. So I think that's all for this stoichiometry. We will end our video here, and thank you very much. See you again on the next video. Assalamualaikum warahmatullahi wabarakatuh, and bye bye.